It's no doubt that submarines are some of the most intriguing pieces of engineering out there, secretive but easily recognizable by almost anyone. Now, there are different types of submarines and all have different purposes. There are about three main types, namely ballistic missile subs, attack subs, and cruise missile subs, whose names are basically self-explanatory. One main and important design of submarines is their propeller, which we will cover in depth in a future video, but submarines have to be designed in a certain way for them to interact with water in the best way possible. This is called hydrodynamics, basically like aerodynamics, but for water as a medium. Now, a few months ago, I had a question that popped up in my mind that how would the hydrodynamics of a submarine work if for whatever reason we had to strap on some wings on a submarine and let it fly without modifying any of its fundamental design. I started looking into different submarine designs and wanted to pick a design that would give this project a better chance of success. For example, I wanted a sub that had control surfaces similar to those on conventional airplanes, or one with a power plant I could imitate, like this Virginia type submarine, which has a pump jet system that I can imitate using this electrical ducted fan, as you'll see later on in the video. I went into my CAD software and settled with this final design. It looks a bit funny, but there is a reason behind its particular shape. If we look on the side profile, we can see that I modeled it against the NASA airfoil NACA 20. This is to give this fuselage a great aerodynamic advantage. In aeronautics, such a craft is called a lifting body. It's basically a fixed wing aircraft or spacecraft configuration in which the body itself produces lift. Some examples of aircraft that use this concept are the famous B-2 bomber and also the NASA experimental aircraft X-24A and X-24B. You will notice that I did not modify anything on the control surfaces. These are not optimized for flight, but these are the ones used on subs and other marine vessels. But I decided it would be nice to model some detachable wings as well, so that I can see how the submarine will behave flying as a conventional aircraft. After my final design, I started preparing the parts for 3D printing. I basically could 3D print this in 4 parts: the nose, the mid fuselage, and the end section, and also the wings. And finally, I would 3D print the control surfaces too. And after many hours of printing and all my parts ready, it was time to glue everything together. Starting with the wings, here is the build montage. And for easy access to the electronics, I designed these slots on the fuselage that would make the submarine come apart very easily and still strong enough to hold it all in one piece. Now, I wanted this submarine to fly in two configurations, as a rocket and as a conventional airplane, and test out how its aerodynamics will perform, especially the control surfaces. So for it to launch as a rocket, I had to design and 3D print this special launch pad. I also did a lot of electronics off camera, and you can also notice that this thing looks a lot different from what it had initially looked. Firstly, I have added two outboard motors on the submarine. I don't even know if I should continue calling it that, but anyways, I had noticed that the submarine was underpowered a lot. So this EDF can only produce about 750 grams of thrust, and the weight of this thing was way over that when we consider the electronics and the battery. So I added these two motors for more thrust, and also so that I can better control this flying submarine. The motors were to produce vectored thrust, so they are controlled by servos and always move in opposite directions to keep the submarine from spinning along its vertical longitudinal axis. As you know, rockets have a tendency of doing that. So now this thing just became more and more complicated. Anyways, I sorted out all the electronics. And it was time for some testing, and this happened. One of the links I designed to connect the three sections of the submarine wasn't strong enough to support the weight of the motors that were pulling down on it below. I had noticed this already and tried adding more reinforcement by taping the linkage, but it seems it wasn't enough. I'm lucky that the motor driving the propellers have a delay, which means the EDF runs up first before the prop motors kick in. Otherwise, I was gonna cut myself here, which is why it's important to never do test runs with propellers on the motors. So the fuselage broke in two, but it was an easy fix and I was back to testing with the help of a friend. This is an indoor test of 70% thrust. On another day, I then decided to take it out and do some more tests at 100% power, and so to see how it will perform. I had a few issues on the day. The one issue is that it just began being windy out of nowhere. And the second issue I had is that the brushless motors which were driving the propellers were not powering up to full power. I don't know if it's because I was using a single battery to power both outboard motors and the electric ducted fan and also the electronics. My transmitter joystick was all the way up to 100% throttle, but I still wasn't getting the thrust I was supposed to. And also I realized that the more I kept testing and running these motors, the less the thrust I was getting out of them. You can listen to the frequency of the noise as I power up the motors at first compared to a few seconds afterwards. It's as if they were lacking power or something. Perhaps the ESCs were heating up too much. I did check for this and their temperature wasn't so bad. So this is where I ended my experiment. This project was going on for too long and I had to release this video. I may do some further modifications to this thing in the future and see if we can get it to actually fly. But with that, if you've made it up until this far, I would like to say thank you for watching, and please subscribe and like this video or share it if you want. And also please follow me on Instagram on anything that flies_. Thank you and see you next time.